Hello everyone, I am Pooja HR. I am studying MSc Chemistry at JSS College of Arts, Commerce and Science, Ooty Road, Mysuru. Today we are going to learn about the introduction part of spectroscopy. Spectroscopy is the study of interaction between electromagnetic radiation and matter as a function of wavelength. Spectroscopy is the use of absorption, emission or scanning of electromagnetic radiation by matter in order to qualitatively or quantitatively study of matter. The matter can be atoms, molecules or solids. In fact, historically, spectroscopy refers to the use of visible light dispersed accordingly to its wavelength, example by a prism. Later, the concept was expanded greatly into include any radiative energy as a function of its wavelength or frequency. Spectroscopic data is often represented by an emission spectrum, a plot of response of interest as a function of wavelength or frequency. Spectral measurement devices are referred to as spectrometers, spectrophotometers, spectrographs, or spectral analyzers. Electromagnetic radiations. Electromagnetic radiations, light is a form of energy whose behavior is described by the properties of both waves and particles. Some properties of electromagnetic radiation, such as its frequency, refraction, it passes from one medium to another, are explained as best in figure 1 by described light as a wave. Other properties such as absorption and emission are better described by treating light as a particle. The exact nature of electromagnetic radiation remains unclear as it has since the development of quantum mechanics in the first quarter of the 20th century. Here we can see the electromagnetic wave. This is the distance between the crest and trough, we call it as wavelength. Here we can see the direction of electric field and magnetic field. They are perpendicular to each other. Wave properties of electromagnetic radiation. Electromagnetic radiation consists of oscillating electric and magnetic fields that propagate through space along a linear path and with a constant velocity. In vacuum, electromagnetic radiation travels at a speed of light that we can represent c, which is 2.997 into 10 power 8 meter per second, approximately 3 into 10 power 8 meter per second. When electromagnetic radiation moves through a medium other than a vacuum, is its velocity v is less than the speed of light in a vacuum. The difference between v and c is sufficiently small, that is less than 0.1%. The oscillations in the electric and magnetic fields are proportional to each other and the direction of the wave propagation. Particle nature of electromagnetic radiation. When matter absorbs electromagnetic radiation, it undergoes a change in energy. The interaction between matter and electromagnetic radiation is easiest to understand if you assume that radiation consists of a beam of electromagnetic or energetic particles called photons. When a photon is absorbed by a sample, it is destroyed and its energy acquired by the sample. The energy of a photon in joules is related to its frequency by the following equation, that is E is equal to h nu, where h is Planck's constant, nu is frequency, E is energy of a photon. The Planck's constant value is 6.626 into 10 power minus 4 joules seconds. Then we come to the techniques which can study on spectroscopy. The reflection of light. Reflection is a process whereby incoming electromagnetic radiations is reflected after interaction with the surface of an object. Scattering of light. Scattering is a random process whereby electromagnetic radiation is absorbed and immediately re-emitted by particles or molecules. Absorption of light. Absorption is a process whereby electromagnetic radiation is absorbed by a particle or molecules and converted into another form of energy. Then emission spectrum. The emission spectrum of a chemical element or chemical compound is spectrum of frequencies of electromagnetic radiation emitted due to an atoms, making a transition from a high energy state to a lower energy state. The energy of the emitted photon is equal to the energy difference between the two states, that is ground state energy and excited state energy. spectrum. The data that is obtained from spectroscopy is called a spectrum. The spectrum is a plot of intensity of light energy detected versus wavelength of the energy. In spectroscopy, there are various types: ultraviolet and visible spectroscopy, infrared spectroscopy, emission spectroscopy, absorption spectroscopy, molecular spectroscopy, etc. Thank you.